Good morning or good afternoon. It just really depends on when you're watching this video. So, since we have another snow day on Wednesday, um, I decided that we're going to go ahead and take notes on our next topic because we really need to finish this unit and take our test on Friday. So, today we're going to learn how to find the greatest common factor and the least common multiple of two numbers. So, I would suggest you go ahead and pause the video now, go to your book bag, and get out your math notebook. Okay? You're going to turn to a new page in your notebook and you're going to copy down notes on least common multiple and greatest common factor. So if you have not paused the video, go ahead and pause it, go get your notebook, and then let's get started. So our learning target, I'm learning to determine greatest common factors and least common multiples using a variety of strategies. Success criteria, I am successful when I can find the least common multiple and the greatest common factor of two numbers to solve realistic problems. So we're going to learn how to find the greatest common factor, and we're going to learn how to find the least common multiple, and I'm going to teach you one strategy to use for both topics. Table of contents, we'll get to that later. Okay, so we're going to use what we call the ladder method to help us find greatest common factor and least common multiple. Why did it do that? Miss Mackie does not know. See if I can make it bigger. Nope. All right, so we're going to use the ladder method. Okay. And we're trying to find the greatest common factor and the least common multiple. So GCF is the greatest common factor. The greatest common factor. And then LCM is what we call the least common multiple. All right, so two words you need to know: factor. So both kind of deal in multiple, both kind of deal with multiplying. But the easiest way to describe a factor is the two numbers that you multiply together to get a product. So factors of 4 would be 1 and 4, because 1 times 4 makes 4, and 2 times 2. So factors of 4 would be 1, 4, and 2. So another example, factors of 8 would be 2 times 4, 1 times 8. So those are factors, the numbers you can multiply together to get a product. Multiples, the easiest way to think of multiples is skip counting. When we're counting by twos, that's called skip counting. So multiples of 2 would be 2, 4, 6, 8, 10, and so on. Multiples of 5 would be like 5, 10, 15, 20, and so on. So those are multiples, those are factors. Okay, so we're finding greatest common factor. We're going to look at two numbers, and we're going to and normally if you made a list of these, you would show all the factors of both numbers, and the biggest factor that they have that is the same is called the greatest common factor. And then when we're looking at least common multiple, we would make a list of all the multiples, and the smallest multiple that they both have that are the same would be the least common multiple if we were going to make a list. But we're not going to make a list. We're going to use the ladder method. So to use the ladder method, the first thing you need is the ladder. So basically you're just going to write both of your numbers 48 and 80, and then I'm going to draw like an L under them. So I'm going to make like a little ladder, draw like a little L under the numbers. And then from there, I need to think of a factor that they both have that's the same. So some numbers that if I had to build the numbers by multiplying, what is the number that they will have the same, or what is the number that they both can be divided by evenly, if you want to think about it as being division. So if you can't think of a number that they both have the same, Miss Mackey knows a couple off the top of her head. I know multiple ways to make 48. I know multiple ways to make 80. So some factors of 48 and 80 would be 4 and 8. So you're thinking of the numbers you can multiply together to get this number, and it has to be a number that you can use for 48, and it has to be a number that you can use for 80. If you cannot think of a number, an easier trick that you can use is if your numbers are even numbers. So even numbers end in 0, 2, 4, 6, and 8. So if your numbers are even numbers, you can use 2 as the factor to start off with. You want to use the biggest factor possible that they both have in common, but if you can't think of the biggest one that they both have in common, and you know that they're even numbers, you can just start with 2. So we're just going to start with 2. And I'm going to show an example of using something other than 2, okay, after we do this one. So once you come up with a factor that both numbers have in common, now we're going to be dividing, okay? So we're basically always dividing on this. So 48 divided by 2 is 24. 80 divided by 2 is 40. So remember, you can always use your Desmos calculator to help you with the division here. So you should always be using that calculator because that's the same calculator that you're going to have on the Georgia milestones at the end of the year. So once we divide it, we have 2 numbers under our ladder. And in order to stop dividing or stop using your ladder method, the 2 numbers at the bottom of your ladder have to be prime numbers. So you say, Miss Mackie, what is a prime number? So a prime number is a number that only has, let me write that better. A prime number is a number that only has 2 factors, the number 1 and itself. So a prime number would be 2 because the only way to make 2 is 1 times 2. So a prime number is a number that only has 2 factors, the number 1 and itself. Another prime number would be 3 because the only way to make 3 is 1 times 3. So you're going to keep dividing until you have at least one prime number at the bottom of your ladder. Since we do not have one prime number, we're going to draw another branch of our ladder and keep going. So what is a number that 24 and 40 would have in common? I can think of a couple of them. 4 maybe, for example. Probably still 8. I could probably use 8 again. But if you can't think of the factors 4 and the factors 8 for 24 and 40, but you know that 24 and 40 are even numbers and you want to use 2, using 2 again is perfectly fine. So we're going to use 2. 24 divided by 2 is 12. 40 divided by 2 is 20. So once you find your factor, remember you're just going to divide the numbers on the inside of your ladder by the factor on the outside. Is 12 prime? No. Let's erase down here. List prime numbers. So let's see. 12 prime. How many ways I can make 12? Let me see. 1 times 12, 3 times 4, 2 times 6. 3 ways I can make 12. 12 has 1, 2, 3, 4, 5, 6 factors. So 12 is not prime. 20. How many ways I can make 20? 2 times 10, 5 times 4. Is that it? 1 times 20. So there's 6 ways where there's 6 factors of 20, so it's not prime. So since it's not prime, I'm going to draw another line on my ladder here. And I'm going to keep dividing. And when I saw 12 and 20, I thought of 6. No, 6 is not going to work. 4, right? You could use 4 here. But if you didn't know you could use 4, and the only thing you can come up with is 2 because they're even, you could have used 2. So in this example, I'm just going to show you how you can use 2 all the way down. And then I'll do another example of how you could have used a different number. So 12 divided by 2 is 6. 20 divided by 2 is 10. Is 6 prime? No, I can make 6 2 ways. Is 10 prime? No, I can make 10 2 ways. So neither one of those are prime. So we're going to draw another ladder branch. We're going to keep going. So 6 and 10, what do they have in common? I can't think of any other number than 2 because they're still all even. So 6 divided by 2 is 3. 10 divided by 2 is 5. Is 3 prime? Yes, we talked about 3 being prime over here. But 5 is also a prime number. So since both of these are prime, although we only needed 1 to be a prime, but since they're both primes, that means I can stop drawing my ladder. I'm done here. I can stop right here. I don't need to do any more dividing. Now, could I have used a different number? Yes. So let's look at an example over here. We had 48 and we had 80. And I started with 2, but remember I said that maybe I could have used 4. So I'm going to use 4 here. 48 divided by 4 is 12. 80 divided by 4 is 20. 12 is not prime. 20 is not prime. So I'm going to draw a little ladder and I'm going to keep going. What does 12 and 20 have to get in common? I could use 2 here if I wanted to, but I know that they have 4 in common, so I'm going to use 4 again. 12 divided by 4 is 3. 20 divided by 4 is 5. So see how I got the same prime numbers? Another way, another one I could use, so I could use any factor that they have in common to start my ladder, and I will still get the same answer at the end. So I know that they both have 8 in common. So 48 divided by 8 is 6. 80 divided by 8 is 10. And then 6 and 10 are not prime, so I'm going to use 2 here. And I would have got 3 and 5. So see how my ladder, all my ladders ended with prime numbers, and I have different values on the side of the ladder, right? So you can use any factor they have in common that you know. If you only know 2, and if they're even and you only know 2, keep using 2, okay? Now, how do you find the greatest common factor? So, greatest common factor, you're going to look at the numbers on the side of the ladder. That's how you find the greatest common factor. The numbers on the side of the ladder. And you're going to multiply those numbers together. So to find the greatest common factor, you take the numbers on the side of the ladder and you're going to multiply them together. So 2 times 2 times 2 times 2 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So the greatest common factor would be 16. So 4 times 4 here would be 16. 8 times 2 here would be 16. So technically, we still got the same answer, right? We just did different factors to start off with. So to find the greatest common factor, you will multiply the numbers on the side of the ladder, okay? If it's only one number, that one number would be the greatest common factor. If there's multiple numbers on the side of the ladder, you will multiply them together to get the greatest common factor. Least common multiple is different. So find the least common multiple, you're going to use all the numbers all the way around the ladder, and then they make kind of like a little L shape. So least common multiple, you will multiply all your numbers around the ladder. So 2 times 2 times 2 times 3 times 5. Ms. Mackey's going to put that in her Desmos calculator because that's a lot of numbers to try to multiply in my head. And you're going to get 240. So the least common multiple would be 240. So here for least common multiple, you multiply all the numbers around the ladder and you will still get 240. And here for the least common multiple, you multiply all the numbers around the ladder and you will still get 240. So greatest common factor, you're going to multiply the numbers on the side of the ladder. Least common multiple, you're going to multiply the numbers around the ladder. Okay, so first you have to do the ladder, divide it all the way down so you have a prime number, and then you can either find the greatest common factor or find the least common multiple. So first we're going to do some examples, find the greatest common factor, and then we're going to do some examples, find the least common multiple. So please make sure you're copying down these notes in your math notebook. All right, so greatest common factor. Let's go to the next slide. Oh, here it is. Oops, too far. So the greatest common factor, we're going to start with these. We're going to do these 3 examples. Why does it keep doing that? I don't like that. Okay, so we're finding greatest common factor, so GCF of 90 and 99. So first things first, I'm going to draw my ladder. So I'm going to make a 90, and put 99, and I'm going to draw a little L shape under it to make my ladder. And then I need to think of a factor that they both have in common. Okay? So what are some ways I can make 90? What are ways I can make 99? And they should both have a number that's the same. Those are where factors are. And we're making it by multiplication. So if you looked at this and you thought, oh my gosh, I think I know. I think it's 9. You would be right. Because the factor of 90 and 99 is 9. 3 would actually work as well. But 9 is, I think, would be the most obvious one to use. You can't use 2 because 99 is not even. So you could use 9, or you can probably start with 3 here if you wanted to. So I can show you how to use 3 here as well. But if you saw 9 for 90, because 10 times 9 is 90, and 99, it has 2 9s anyway, so you know it's going to be, the factor is going to be 9. That was the best bet. So once we have our factor on the outside, we can divide. So 90 divided by 9 is 10. 99 divided by 9 is 11. So once I do my division and I have numbers at the bottom of my ladder, now we have to figure out if we're done or we need to keep dividing. So in order to be done, one of your numbers have to be prime. So let's check these numbers. So we got 10. Let's see how many ways I can make 10. 2 ways to make 10, so 10 is not prime. How many ways to make 11? 1 way. So 11 is prime. So since 11 is prime, I can stop. Okay, so once one of my numbers is prime, that means I can stop dividing, and now I can just find my greatest common factor. So remember here, we're only finding greatest common factor. We'll do least common multiple later. So the greatest common factor is the number on the side, or the number or numbers on the side of your ladder. So we only have one number here. So the number on the side of my ladder in this example is 9. So my greatest common factor is 9. If I had multiple numbers on the side of my ladder, I would just multiply them together and I would still get 9. Okay? So if it's one number on the side of your ladder, that's the greatest common factor. If there are multiple numbers on the side of your ladder, you multiply them together, and then that's the greatest common factor. So let's look at an example of using a different number. So if I use 3 here, remember I said you could possibly use 3. It will look like this. So if I started with 3, 90 divided by 3 was 30. 99 divided by 3 is what, 33? And then I would keep dividing because 30 and 33 are not prime. And I would probably use 3 again here. 30 divided by 3 is 10. 33 divided by 3 is 11. So we'll see how I ended up with the same prime number here. And then to find the greatest common factor, you would multiply the numbers on the side of your ladder. So GCF would have been the same. So 3 times 3 is 9. So you still got 9 as your greatest common factor. I just started with a different factor. So I started with a smaller factor compared to a bigger factor that they both had in common. So you're just trying to find the factors that they have in common, and you want to use the one that comes to you more quickly. It doesn't matter if it takes you a longer time to do it, as long as you're coming up with the correct factor. So let's look at example 2. We got, what's that, 18 and 24. Remember, we're finding greatest common factor. So we got 18, we got a 24. We're going to draw a line. So I need to think of factors of 18 and 24. All right, so what are some ways to make 18 and 24? And what is the number that they both have that's the same? The first number that comes to my head is 3. I could also use 2 because they are both even numbers. We probably could have used 6. Yep. Or, yeah, we probably could have used 2, 3, or 6, whichever one we want to start with. But since 3 was the first number that popped in my head, you know what? No, let's just use 2. Because we could have used 3. I'll use 3 in a second example. So let's use 2. Because they're both even numbers, so I'm going to use 2. So 2 is my factor. So now I divide. 18 divided by 2 is 9. 24 divided by 2 is 12. Is 9 prime? Let me see. How do you make 9? 1 times 9, 3 times 3. Nope, 9 is not prime. 12. I know 12 is not prime. 1 times 12, 2 times 6, 3 times 4. So neither one of these guys are prime, so I'm going to draw another branch and keep going. All right, so what does 9 and 12 have in common? Not 2, because 9 is not even. So 3, yes, for sure. Because I know right here, when I make my little list, I saw 3 on this list, and I saw 3 here, right? So they both have 3 as a common factor. So I'm going to use 3 here to divide. So 9 divided by 3 is 3. 12 divided by 3 is 4. So my next step is to see if my numbers are prime before I stop, is 4 prime. 1 times 4, 2 times 2. Nope. It's 3 prime. Let's see, 1 times 3. Yes, 3 is prime. So since 3 is prime, I can stop dividing, and now I can find my greatest common factor. So I'm just going to multiply my numbers on the side of my letter right here. So my greatest common factor would be 2 times 3, which is 6. Greatest common factor would be 6 for 18 and 24. Now, let's look at an example of using a different number. What did I say? We could use 3. Remember Miss Mackey said, oh, possibly 6. So let's see what would happen if I use the biggest factor possible, which was 6. 18 divided by 6 is 3. 24 divided by that is 4. So you can see how the greatest common factor would have just been 6. Or if you would have started with 3 here. 18 divided by 3 is 6. 24 divided by 3 is 8. You would have got 6 and 8, which are not prime. And then you could have used 2 and got 3 and 4 here. And you would have still got 6. See? So it doesn't matter what factor you start with, as long as you're using a common factor of both of the numbers. And then the last one, we're going to find a GCF of 125 and 300, which is her big numbers, right? So let's look at these numbers. A factor they have in common. Let's see. Let's try 2. 125 is not even, so I can't use that. 300 is even, but 125 is not even, so I can't use that one. Possibly 3. So to check the numbers to see if there are factors, you would divide them by each number and see if you get a whole number. And if you get a whole number, you can use it. So you could divide 125 by 3 or 300 by 3. And if they both ended up as whole numbers, then that number would be a factor of it. But another trick that Miss Mackey can teach you is if a number ends in 5 or 300 or a 0. So if a number ends in 5 or a 0, they are both divisible by 5. So we can use 5 here. So in your calculator, 125 divided by 5, what is that, 25? So let me get my calculator. So 125 divided by 5 is, yep, 25. Okay. And then 300 divided by 5 is 60. Now I know that 25 is not prime because I know that 5 times 5 is 25 and 1 times 25. So that's not prime, and we know 60 is not prime. There's a lot of ways to make 60. So since both numbers not prime, I'm going to draw another letter here. And I'm going to keep dividing. So, change color. What do they have in common? Probably going to be 5 again, because this ends in a 5, this ends in a 0. So if they end in a 5 or a 0, you can use 5 as a factor. Not 3. Definitely not 3, because 25 divided by 3 is going to give you a decimal. 60 divided by 3 will give you a whole number, but you need whole numbers for both. So the only thing we could use in this instance is 5. So 25 divided by 5 is 5. 60 divided by 5 is 12. 5 is prime, because the only way to make 5 is 1 times 5. 12 is not prime. But since 5 is prime, we can stop. And then we're going to use the numbers on the side of my ladder to find the greatest common factor. And so I'm just going to multiply those two numbers together. 5 times 5 is 25. So the greatest common factor is 25. So which means, actually, if you knew something about your 5 times tables or your 25 tables, you could have started with 25. Let me check 3. Remember I said maybe 3? So 125 divided by 3 is a decimal. 300 divided by 3 is a whole number. So no, you couldn't use 3 to start off. The only number we could have used here was 5 or 25. So that's how you find greatest common factor. So greatest common factor, you're going to use the number on the side of your ladder. Now let's look at least common multiple. So least common multiple is the next slide. And then if you want to pause, here's some more examples that you can work on. We are going to go over these in class. So if you want to pause, write these down and try them, you can. But let's move on to least common multiple. Okay, so we're going to find the least common multiple of 6 and 15. So, where is my pen? So you can use the ladder method again for both of these, or for these examples. Okay, so remember, draw your ladder. So we got 6, we got 15, we're gonna draw a ladder. And then you need to find some factors that 6 and 15 have in common, or a number that they both have in common that they're both divisible by. 6 is even, 15 is not, so we can't use 2. What else do I know about 6 and 15? Some ways to make 6, let's see. You can't use 1, so 1 is never going to be a way to start because you're just going to get the same numbers over and over again. 2 times 3 makes 6. 3 times 5 makes 15. Okay, so we can use 3. So let's use 3 as a common factor. So 3 goes on the outside, and then we're going to divide. 6 divided by 3 is 2. 15 divided by 3 is 5. So remember, you can only stop dividing when you have prime numbers. 2 is definitely prime because the only way to make 2 is 1 times 2. And then how do you make 5? 1 times 5, actually. So 5 and 2 are prime, so that means I definitely can stop. All right, now, least common multiple, remember, is different. So what? Okay, stop that. So least common multiple, LCM, is now we're going to be multiplying all the numbers around the ladder. It kind of makes an L when you draw it. So least common multiple would be 3 times 2 times 5. 3 times 2 times 5 is what? 6 times 5 is 30. So least common multiple would be 30. Remember, the greatest common factor, you're going to use the numbers on the side of the ladder. The least common multiple, you're going to use all the numbers around the ladder. Okay, next example, we got 6 and 8. So 6 and 8, draw your ladder. All right, what does 6 and 8 have in common? Not the 3, can't use 3. Oh, they're both even, so we're going to use 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. And from my last example, I know that 4 is not prime because 1 times 4 is 4 and 2 times 2 is 4. So it's multiple ways to use 4 to make 4. So 4 is not prime. But there's only one way to make 3, which is 1 times 3. So 3 is a prime number. So that means I can stop as soon as I get a prime number. So to find the least common multiple, I'm going to multiply all the numbers around my ladder on the outside, never the inside. The least common multiple would be 2 times 3 times 4. What's that? 2 times 3, 6 times 4 is 24. So the least common multiple would be 24. Okay. And then the last one, we have 4 and 10, and we're finding least common multiple. The only thing they have in common is 2 because they're both even. So 4 divided by 2 is 2. 10 divided by 2 is 5. 5 is prime. 2 is prime. So that means I can stop. And then I would just multiply. To find the least common multiple, I'm just going to multiply the numbers around the ladder. So 2 times 2 times 5. It's the least common multiple, which is 4 times 5 is 20. So least common multiple would be 20. So that's how you can find the least common multiple. You multiply all the numbers around the ladder. The greatest common factor would be the numbers on the side of the ladder. So for number 9, the greatest common factor would be 2. For number 8, the greatest common factor would be 2. And for number 7, the greatest common factor would be 3. So you can find both using the ladder method. Okay, so here is a slide that has some examples. So you can pause and try those examples. We'll go over those in class. And then you should be working on more practice that's included with the assignment list. So make sure you copy down the notes, and hopefully I'll see you on Thursday to continue working on greatest common factor and least common multiple. Bye. Oops, how do you get off this? That is unfortunate. Hold on, y'all. Miss Mackie can't get off our slide. There we go. Don't know what I'm doing.